Alright, hello. Today we're going to be working on finite state machines in Unity and how you can use them to make your own little boss battle. So first we're going to go over what a finite state machine is. So if I run this right now, I can show you. But essentially what it is that it's a little thing you have in your code that keeps track of whether something is doing a specific action or state you want it to be in. So let's say that you have def states, you have jumping states, you have boom states. See? So when I'm moving, it turns to a moving state and it turns blue. When I'm jumping, it turns blue because I'm in an aerial state. And then if I touch the enemy, I go red and I can't move anymore because I'm in my death state. So a state machine processes all these states and shifts between them and makes sure nothing is really overlapping with each other because only one state can be active at a time. Alright, so here we're going to go over the generic class for a base state and a state machine. So a base state, or just a state in general, is going to have two main parameters, and it's going to be the name for the state, and the state machine it's going to be inside. And we're using the protected here, so only the base state and the state machine can really access the state machine of the base state. And then each state is going to have four main actions: an enter phase, so this is what happens when you enter the state. State logic, so this is going to determine if we're going to move on to another state. Action, which is what actually is happening to the game object during this state. And exit, which is the effect we're going to have once we leave this state. And then state machine, this is the generic class for state machine. It's going to have one thing, and it's going to be the current state. So our current state is actually going to dictate what's going to happen within the state machine. So this is just a not empty state function. So once we start the state machine, we're going to want to get the first state and just set it equal to that. And then once we set it equal to that once our current state is equal to that first state, we're going to want to enter that first state, or do the enter phase. And then on the update and late update, we're going to do the state logic and action part of our current state. And then if we want to change state, first we have to exit our current state and then enter a new given state. And then this is our get first state statement. It's just here to override later, so don't worry about it too much. Right now, just set to null. But for our actual boss AI, right now we have four main scripts, and these are all in the folder in Unity. I just can't swap between them because it's a bit inconvenient with the software I'm using. But we have auto decide, jump attack, and roll attacks as our main base states, and I've already went through jump attacks and roll attack and did the skeleton, but I'll go through it in auto decide. And we have boss of them, which I'll build from scratch here. So auto decide, the first thing we're going to want to do is get rid of this little red bar because we're inheriting from base state. And when you're inheriting from base state, it's going to yell at you until you make a constructor. So we're going to do public auto decide state machine SM, and then we're going to put a colon here, and then say we're going to use our given inherited constructor, and just say we're going to type in decide state, or just for deciding the next action, and we're going to put an SM as our state machine. And then we just do that, and bam, no more red line. And these are all just override commands for our basic functions right here. And then the base dot thingy is, like I said, just the inherited part, which right now is nothing. As for setting up our state machine, the first thing we're going to want to do is set up public variables of all the different states you want to have. So we're going to do idle decide, public jump attack, public roll attack, and then we're also going to want to do a public void awake function. So when our state machine is first called, we want to set our list.idle state to a new, set it to a new idle decide, where it's hooked up to this state machine. Alright, one small thing before we get on to the actual logic and action of our idle state. First, we're going to add a boss SM, called SM. I changed the input for the constructor to STM, and we're going to set our new private SM to a boss SM of this dot state machine. Not state logic, state machine. And this is because our boss SM now has a rigid body and a player, but our regular state machine does not. And our base state constructor only takes in a state machine. So if we're trying to access variables within this state machine, within the boss state machine, then we're going to have to cast every reference to it as a boss state machine. So this just makes things easier. But now for the actual logic of changing states, we're going to want to have a distance that we can change from our state machine. So we're going to add a serialized field, public. I know it's not necessary, I just like doing it. We're going to do this in int, and we're going to call this decide distance, or decide dis for short. And for this logic, or my bad, we're not supposed to erase that, but we're going to put an if right here, and we're going to do if our state machine, player and for state machine, transform position, and what I actually wanted to do was vector2, there we go, dot distance, yeah, vector2 dot distance of our position of our player with our SM dot, what was it, rigid body dot position. So if the distance between our rigid body, which is our boss, and our player is less than, let's say, well, the SM decide distance, then we're going to want to do sm.change state into our roll attack. No, our jump attack. That's our close-up attack, which is going to be our sm.jump. My bad. Sorry guys, this is multiple takes. And then we're going to do an else statement. Else, we switch to our sm.change state, sm.roll. So now, our idle state will change into a jump attack if the player is close enough, or to a roll attack if the player is too far. But we want a little bit of downtime so the boss can kind of give the player a little bit of breathing room. So to do this, there's timers in Unity, but I just like doing it in a good old-fashioned counter. So we have public int counter. Set this to around 240. This time I find works. You can probably serialize it in here, but for the sake of time, I'm just going to do it right here. In action, we want this counter to count down, so counter, minus, bam. Well, I'm just going to not do that and actually declare it when we enter, so we have something when we enter. Haha. Neat. So our counter says to 240 when we enter. It goes down every time, which is our action, or every frame. And then we're going to put this whole logic sequence in a big if statement. So if counter is less than 0, then you will do this. So I'm just going to bam. Alright, and here we have our idle state. Alright, for the sake of time, I already finished the jump attack and the roll attacks through the magic of editing. And I also added a public int of jump attack height and a roll speed, also through the power of editing. And a sprite renderer, so we can change colors whenever we're switching between phases. So I'm just going to do that real quick with our idle side. Our sprite renderer in our state machine is called SPR. In order to do that, we just do, whenever we enter, we do sm.spr.color equals color dot gray. We're just going to do a quick rundown of our things. So when we enter our jump attack, we want to see which way we're facing, the player relative to us, and then we go up. And then for action, we go sideways. And then when we exit, we stop in place and do a little hop. And then for actual logic for changing states, once we hit a wall, our velocity will go the opposite direction and we'll stop. And a roll attack does the exact same thing, except our velocity will actually go up when we hit a wall, so I'm just using that to measure it because I was doing some. And then our action is rolling. Our exit, we do a little hop and stop. And our enter, we change color, we figure out directions. And then I'm going to showcase the final product. Alright, and here's our final product. As you see, it starts gray, and then transitions to the pink when it's doing the roll attack when I'm further away, and when I get up close to it when he's starting to attack, he does his little hop. And yeah, that's state machines.